If you watched my last couple of videos, you know that the first thing I'm going to do when I try to write the equation of a parabola is make a rough sketch of what this looks like. That's going to help me determine which model to use up here for my equation. So this time we're given the focus and the directrix. The last videos we were given other information. It doesn't really matter, we're going to start with that sketch. So this time my focus is at the point 1, 3, so I'll go ahead and make a point about there. Again, it's just a rough sketch, doesn't have to be super accurate. Remember, the parabola will not pass through the focus, it wraps around the focus. My directrix is going to be the vertical line at x equals 3, so count 3 spaces, there's going to be my directrix. So all this tells me, and I'm going to be careful about how I make my rough sketch this time, but all this tells me is that my parabola must look something like this. It needs to wrap around the focus and curve away from the directrix. So roughly like that. Now, all that tells me, it actually tells me a lot just based on that. Since I have a sideways opening parabola, that's going to be the y-squared model to use. So this is going to be the model that we're using. However, I need to find out some details because I don't know the h and k values. I don't have the vertex this time. And I also don't know the p-value, which is the distance between the vertex and focus. So let's go back to that sketch. The reason I said I'm going to be careful with how I graph it is even though I don't know where the vertex is necessarily, I can find it pretty easily. Your vertex needs to be smack dab in the middle between where the directrix and the focus is going to be. So I can do that a few ways. I can find the average between this point and that point right there, which I guess would be 3, 3. I could find the average, or if we sketched it out, if we're really careful, we can eyeball that and we can see that exactly halfway in between is going to be the point 2, 3. So my vertex must be at the point 2, 3. Again, you can find that with midpoint formula, you can find that with average. You have a few different ways. My preferred way is, if it's easy enough, sketch it out and just find out what's in the middle of those 2 points. So there's my vertex, which, remember, the vertex is going to represent the h and k in your formula. So let's start with that. We can actually write most of our equation just knowing the h and k, and we'll come find the p-value in a second. So this time I'm, again, using the y-squared equation because I have a sideways opening parabola. So I'll start with y minus the k value. Since the k value is a positive 3 in the parentheses, I'll have a negative 3. Those always change signs. So y minus 3 squared is equal to 4, which is just part of the equation, times the p value. I'm just going to leave that blank for right now. And then times x minus the h value. The h value this time was 2. And again, those will always change signs, so we'll have a negative 2 or a minus 2 in the parentheses. Alright, so all that's left to find is the p-value, which is the distance between the vertex and the focus. Since I now have both of those points on my graph, once again, I should be able to either just count that if my graph is pretty accurate, or I can do subtraction. The focus was at the point 1, 3. So the distance between those points must be 1. Either count it out or look at your graph and you should see that you have a distance of 1. And that is the p-value. However, since the graph opens to the left, I guess I should technically say it's a negative 1, since my focus is to the left of the vertex. So the p-value is negative 1. So going back to my equation then and just plopping the p-value in there for negative 1. There's my equation. I guess what I'll do, let's get parentheses so it doesn't look like we're subtracting. I guess what I'll do as a last step is let's just multiply the 4 and the p-value together. So y minus 3 squared would equal negative 4 times x minus 2. If you want to distribute on the right hand side, go for it. Otherwise, I'm going to say that is my equation for the parabola described up above.